question. Over here I have only 2 numbers. In the previous question I had 3 numbers. Same like previous questions I will solve, but the difference is I have 2 numbers over here. So the first number is 105. I have to find all the possible factors for this number. So I put this in divisional bracket, factorization bracket to get the factors for it. 105. 1 plus 5 gives me how much? Gives me 6. Right? That is 1 plus 0, 1. 1 plus 5, 6. 6 is divisible by 3. So I can say that 105 is divisible by 3. So let us divide 105 by 3. 3 3s are 9. 3 3s are 9. But I have 10 over here. Means 1. So 1 I will write it over here. 3 5s are 15. Right? So 5. Now 35. 35. 5 plus 3 gives me 8. 8 is not divisible by 3. So I can say that 35 is not divisible by 3. So now I will divide it by what? 5. Test of divisibility by 5 says 0 or 5 at the end, the number will be divisible by 5. So I have 5 at the end, means this number will be divisible by 5. So let us divide it by 5. 5 7s are 35. So 7 over here. 7 again a prime number which comes in the table of 1 and itself, that is 7. So I cannot write 1 over here. 1 cannot be a factor in factorization method. So what I will write? 7, because 1 I needed over here. If I write 1 over here, I will get 7 again over here. Then wapas 1, then 7, 1, 7. It will be endless. I want 1 over here, so I have written 7 over here. So the possible factors for 105 are what? 3, 5, 7. So these are the 3 factors, 3, 5 and 7. Now I will find the factors for 154. So 154 inside the factorization bracket. I have even number, that is 4 at the end. Means what? This number, entire number will be divisible by 2, because test of divisibility says even number at the end, the number will be divisible by 2. So let us divide this number by 2. 2 7s are 14. So I will write 7 over here. But over here I have 15. So 15 minus 14 gives me what? 1. This one I will write it over here. Again 2 7s are 14. So 7 over here. I got 77. This number can be divisible. Easily I can make out that this number will be divisible by 7. Because 7 ones are 7, 7 ones are 7. So let us divide it by 7. When I divide it by 7, I get the answer as 1, 1, 11. Again 11 is a prime number which comes in the table of 11 only. So again 11 and the answer will be 1. Now I want to see the common factors. Common means what? I gave you the example, like 2 friends are there. So they both say yes, we have a common habit. Means what? Both of them should have that habit. So same over here. Common means what? Both these numbers should have that common factor or common multiple, common divisor. Means what? This number should have common divisors. So with this I got the factors. Tell me which factor is common. I have 3 over here, but I don't have 3 over here. I have 5 over here, but I don't have 5 over here. I have 7 over here, yes, and yes, I have 7 over here. So I can say that this 7 is common between 105 and 154. So this is a common factor. See, greatest common divisor will be recognized when there are too many factors, common factors. But over here I have only one common factor, so that will be only the greatest common divisor. So the greatest common divisor for 105 and 154 is what? Is 7. Now we will start with the 9th question. Again we have 2 numbers and we have to find GCD. So the first number 56. I will put inside a factorization bracket. अब सबसे छोटा नंबर जो 56 से divisible होगा is what? See, I have even number over here. All numbers which has even number at the end is divisible by 2. So means 56 has even number, that is 6 at the end. So this number is divisible by 2. So let us divide 56 by 2. 2 2s are 4, right? So 2 over here. 2 2s are 4, but I have 5 over here. So 5 minus 4 gives me how much? 1. That 1 I'll put it over here. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14, 2 8s are 16. So I got 8 over here. And I got 16 over here, right? So 28. If you don't know, you can divide 56 by 2. You will get the answer as 28. Again even number at the end means what? This number is divisible by 2. So again I'll divide it by 2. 2 ones are 2, 2 ones are 2, 2 twos are 4, 2 threes are 6 and 2 fours are 8. So I got 14. Again even number at the end means it is divisible by 2 again. So 2 sevens are 14. So 7 being a prime number, it is divisible by 1 and 7 itself. So I need 1 over here, means I have to write 7 over here. So 7 ones are 7. So what are the factors for 56? The factors for 56 are 2, 2, 2 and 7. Now the next number 57. So I'll write 57 inside the factorization bracket. Is it divisible by 2? No, because it does not have even number at the end. So I cannot divide 57 by 2. Then what next? Can I divide 57 by 3? 7, 8, 9, 10, 11 and 12. That is 7 plus 5 gives me 12. 12 is divisible by 3, right? So I can say that 57 is also divisible by 3. So let us divide 57 by 3. I'll write 3 outside the factorization bracket. Inside the factorization bracket I will get what? 3 ones are 3. 5 over here. 5 minus 3 gives me 2. That 2 I'll put it over here. Then 3 nines are 27. So I can say that I'll get 9 over here. I got 19, right? Now 19 being a prime number does not come in any of the table. I can say that 19 के table में आ सकता है 1 के table में. I need 1 over here means what? I have to write 19 over here. So 19 ones are 19. But am I finding the factors? No, I am finding the GCD, that is common divisor, greatest common divisor. So let us check 57 and 56 में common क्या है? 2, I have 2 over here but I don't have 2 over here. 2 over here, I don't have 2 over here. 2 over here, I don't have 2 over here. 7, I don't have 7. Can you see there is no common factor between them? And it is logical also. 56 and 57 किसके टेबल में आएगा साथ में? They both are adjacent number, मतलब एक के बाद एक. 57 is a successor of 56. It can come only in one's table. 156 is a 156, 157 is a 157. If you tell the table of 2, you will get 56 and you will get 58, but you won't get 57 in the table of 2. You can check by 3, 4 and किसी के भी table में नहीं आएगा because they are what? Adjacent numbers. They cannot come in किसी एक table में नहीं आ सकते except 1. So the answer for this is what? The answer for this is 1. Remember, अगर कोई factor common है ही नहीं तो उनका common factor 1 होगा because all the numbers come in the table of 1. 1000 the 1000. So every number comes in the table of 1. So if there is no common factor between these two numbers, I can say that there is one common factor between these two numbers, that is 1. So what is the common factor, greatest common factor, GCD, for the 9th question that has 56 and 57? The answer is 1 because it does not have any common factor. Now we will move with 10th question. In the 10th question I have 3 numbers. I'll find the factors of the first number, second number, third number. Then we will compare. कौन सा factor तीनों में common है? This factor when multiplied, all the factors when multiplied, all the common factors when multiplied, I'll get GCD, that is greatest common divisors. So first I will take 7, 7, 7. The first thing that comes in my mind is this numbers can be divided by 7. 7 ones are 7, 7 ones are 7, 7 ones are 7. So I'll see if I get even number over here, then I'll start with 2. But looking at this number, suddenly I get a click that yes, this can be divided by 7. So I'll divide it by 7. 7 ones are 7, 7 ones are 7, 7 ones are 7. I get triple 1. अब ये किससे divisible होगा? 1 plus 1 2, 2 plus 1 3. 3. The summation of this is 3. 3 can be divisible by 3, so I can say that this entire number can be divisible by 3. So let us divide 1 1 1 by 3. These two numbers. 3 3s are 9. I have 11 over here. So 3 3s are 9. 10 11, that is 21. 7 ones are 7, 7 twos are 14, 7 3s are 21. Or 3 7s are 21, right? So 7 over here. Now I get 37. 37 being a prime number does not come in any of the table except 1 and 37. So 1 cannot be a factor or cannot be a divisor. So I'll write 37 and I'll get 1 over here. See, remember why I'm not writing 1 over here. If I write 1 over there, then it will be 1 over here. Then 137 is 37. I'll get 37. Again 1. Again 37. This will become endless. That is why I am taking the factor as 37 and not 1. So when I write 37 over here, I'll get 1 over here. And this comes to the end of our factorization method. So what are the possible divisors for this number? 7, 3 and 37. Now let us check the divisors for 315. This is the number 315. Looking at this number, I can say that this can be divisible by 5, right? So let us divide it by 5 first. 5 ones are 5, 5 fives are 25, 5 six are 30. And this is 31, which is closer to 30 is closer to 31, right? So I can say that 5 six are 30. 30 over here, but I have 31 over here. So 31 minus 30 gives me how much? 1. That one I'll put it over here. 5 threes are 15, so 3 over here. I get 63. 63 is divisible by what? 6 plus 3 gives me 9. And 9 is divisible by 3. So I can say that the entire number 63 will also be divisible by 3. I am just applying the test of divisibility by 3 over here. So when I divide 63 by 3, 3 ones are 3, 3 twos are 6. So I can say that I'll get 2 over here. Then 3 I have over here. So 3 ones are 3. 21. 2 plus 1 gives me 3. 3 is divisible by 3. So I can say that the entire number 21 will also be divisible by 3. So let us divide 21 by 3. 3 sevens are 21. Now 7 is what? 7 is a prime number. It comes in the table of 1 and 7 itself. So I will take 7 as a divisor. I will get the remainder as 1. This comes to the end of our factorization method for 315. Now the next number, which is 588. So let us find the factors for this number 588. 588 inside the factorization bracket. Even number at the end suggests that this number is divisible by 2. So let us divide this number by 2. When I divide it by 2, 2 twos are 4. I have 5 over here, so 4 is closer to 5. So I can say that yes, I can take 2 twos are 4. So 2 over here, 2 twos are 4, and I have 5 over here. So 5 minus 4 gives me 1. That one I'll put it over here. 2 nines are 18, right? So 9 over here. 2 fours are 8. So 4 over here. Then again 4 means even number at the end suggests that this number can be divisible by 2. So let us divide it by 2. 2 ones are 2. 2 fours are 8. So 4 over here. 4s are 8, but I have 9 over here. 9 minus 8 gives me 1. So this 1 I'll put it over here. I get 14. 2 sevens are 14. So 7 over here. I get the number 147. Okay. This is 7. So I get the number 147. 4 plus 1, 5 and 7. 7, 8, 9, 10, 11 and 12. I get 12. 12 is divisible by 3. So I can say that 147 is also divisible by 3. So let us divide this 147 by 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. 12 is closer to 14. So I can say that 3 fours are 12. So I write 4 over here. 3 fours are 12, but I have 14 over here. Means 2. This 2 I'll write it over here in front of this 7. So I get 27. 3 nines are 27. So 9 over here. I get 49. 7 sevens are 49. So I can say that yes, 49 comes in the table of 7. So 7 over here. 7 sevens are 49. So 7 over here. 7 being a prime number comes in the table of 7 only. So 7 ones are 7. So let us check what are the possible factors, common factors. 7 over here, 7 over here, 7 over here gives me 7 as a common factor, right? 3 over here, 3 over here also, and 3 over here also gives me 3 as the common factor, another common factor. 37 over here, I don't have 37 here, I don't have 37 over here. I am done with this, right? So और कोई factor हो ही नहीं सकता. 7 and 3. 7 1 is 7, 7 2 is 14, 7 3 is 21. So I can say that 21 is the GCD for all these three numbers. All these three numbers will come in the table of 21. और किसी टेबल में नहीं आएगा. बड़ा, the greatest number in which all this number will come is 21. It will also come in the table of 3, and it will also come in the table of 7. It will come in the table of 21 even. So these three numbers, GCD is what? The GCD is 21.